Right. The course website for this course is this one. This is the course website for the course I'm teaching you guys, right? And it contains everything that you need to know, including the videos from every session. So if you go down this, you will see the video for the review session that we had on Monday. And you will also see the videos for the tutorials that we had so far. So I post all the videos in this website here, right? I don't use Blackboard for posting videos, all right? I mean, this website is easier to access than Blackboard because for Blackboard you need to log in, you need to type your username and password and things like that, which is really not friendly, right? Whereas this website, you can access it anytime you like, okay, from anywhere. You don't need any login. You don't need login. You don't need to log in to access this. All right. Okay, guys. Now let me start talking about this session. All right. In this session, you're gonna talk. I'm gonna take you through this tutorial sheet, right, which is about introduction to R, right? R is a free statistical software. So before I can take you through this, I need to install R. Now I already have installed R in my computer, but you might have not. So you might not have installed R. So let me show you how to install R. So the first thing you need to do is to open a browser like this. And then you go to the address and type in www.r-project.org. So you'll get to this page. And in this page, you will click on download R, and it will take you to this page. This is a mirror websites. So you have websites for different parts of the world. So depending on where you are, you will choose the corresponding site. So I'm in the UK, so I will choose this site, right? And it will take you to this page. Now at this page, you see there are three different links, right? There are three different links. The first link is to download R if you're using the Linux operating system. And the second link, if you're using the Mac operating system. And the third link is if you're using Windows operating system, right? So now I'm using Windows, so I will click on this link and it will take you to this page. Now, if you're using R for the first time, you will click on this, right? You will click here and it will then, once you click here, it will take you through a number of steps, right? And you'll be able to install R to your computer, right? So it's very easy to do. It's very, very easy to do. And you shouldn't have any difficulties installing R. Now, I'm not going to install R because I already have R in my computer, right? So I'll close this and I will go into the start button and then go down and choose R. R is over here. There are two options here. One is 386, the other one is 64. You will choose the 64 version because that's more powerful, all right? And it will come up with the following window, right? By the way, if you have any questions, just use the chat room, okay? If you have any questions, please feel free to use the chat room, and I will try to answer them as quickly as possible, right? So you will get to this R command window. Now I'm going to take you through the tutorial sheet. The first thing is, hello guys, can you keep quiet please? The first thing is how to use help. Like if you want help on any particular function in R, you can type help, open bracket, and then say, for example, plot. Plot is a function in R. All right, so that will show you how to use the command plot in R. Right, so this window tells you how to use the command plot in R. All right. Okay, now let me show you some simple stuff. Like if you want to add two numbers, this is how you do it in R. If you want to add and subtract, this is how you do it. If you want to multiply two numbers, you just use the star symbol, right? And if you want to divide two numbers, right, like this is what you will do, right? So it's 2786 divided by 256, right? Okay. And if you want to expatiate something like 4 power 3, this is the symbol you use. So 4 raised to the power 3 is 64, right? And if you want to combine different stuff, like for example, 2 plus 4 times 20 divided by 10 will be this. Now, in this operation, I'm sure you guys know the division comes first, and then multiplication, and then summation. So remember, division first, multiplication second, and summation third, right? And there is a number in pi which is called pi. I'm sure all of you know what pi is. So this is pi up to 6 decimal places. You can multiply pi by anything. So for example, if you multiply pi by 10 to the power 2, this is what you will get, right? Okay, now the next thing I'm going to talk about is how to create objects, how to create objects in R, right? All right, so for example, this command here, what it does is it creates an object called A, which is assigned the value 23. So this backward, this is the simple use to assign. I mean, this backward arrow key, which is this one here, this is the symbol that is used to assign something to something, right? By the way, this symbol here, the number key, is a command line. This is, for example, this is a command line. So anything that you write after the comment, after the number key, is a comment, right? All right, okay. Now, suppose you do something like this. What this means is that you're assigning the value of 5 to an object called B, right? And if you do this, 8 times B gives you 115. If you do this, A divided by B gives you 4.6. And you can assign, right, this, for example. So what you're doing here is that you're creating a new object called C, and that takes the value of 10 times 8 times B, right, which is 1150. Now ls is list. So ls basically lists. So ls, sorry, excuse me, it lists all objects in the session so far, right? So so the objects that you created so far are A, B, and C. So it lists the 3 objects A, B, and C. Now RM means remove, right? So if you type RM A, B, C, it will remove the objects A, B, and C from the session. So RM removes objects from the R session. Okay. Now, if you type ls again, you will see there are no objects left because you have removed the 3 objects A, B, and C. So there are no objects left in R right now. Okay. Now, another thing I need to tell you is suppose I assign the value 5 to an object named X. Now you should type capital X, that is undefined, because the reason for this is because little x and capital X are two different things. So R is case sensitive, right? R is case sensitive, right? So in other words, the small letters and the capital letters are two different things in R, right? Okay, the next thing I'm going to talk about is how to create vectors. Now, if you have any questions, guys, if anything not clear, please use the chat room, okay? I will try to answer you as quickly as possible, okay? So please let me know if anything not clear, all right? All right, guys, thank you. All right, the next thing I'm going to talk about is how to create vectors in R, right? Okay, suppose you want to create a vector, okay, X. Now, what you need to do is you need to use these two things. There's a C, a small c, followed by open brackets, and then you type the numbers that you want in the vector. So it will be, say, suppose you want the following numbers in the vector, right? So let me type that. Okay, so what this command does is that it creates a vector of length 9 that contains these numbers 1.4, 2.7 up to 16. So what you should realize here is that this, you start with the letter C and then open bracket and then the numbers that you want in the vector and then close bracket. So that will produce a vector like this, right? Okay, next thing. Now you can do the usual operations with the vectors. So for example, 2 times x multiplies every single number in the vector by 2. 2 times x plus 1, it multiplies every single number by 2 and then adds a 1. Yes, how do you create a column vector? All right, if you want to create a column vector, you need to use this command T of x, right? So this is a column vector, right? Now what in this command T denotes the operation transpose, right? So if you see x is a raw vector by definition. The transpose of x creates a column vector, right? So this one here is a column vector, okay? Right. All right, that's a good question. Now let me retype x. So this is x, which is a raw vector. Now 1 over x will give you the reciprocal of x. So every element, you take the reciprocal of every single element in x, right? Now there are some operations that you can do with the vector. The length of x is the number of elements in x, right? The sum of x is the sum of all the numbers in x. So if you sum all these numbers, you will get 77.7, right? And mean of x is the average of the values in x. So the average of all these numbers in x gives you 8.63333, right? var of x, var is the variance or the sample variance of x. You may recall on Monday this week, I gave you a formula for the sample variance. Well, I gave you 2 formulas for sample variance. So this command here uses the unbiased formula for sample variance, right? So, and it turns out to be 30.0275. Now the standard deviation is, the standard deviation is this SD of x. Can you guys keep quiet, please? All right, so the standard deviation is SD of X, right? All right, and you can also compute the standard deviation by taking the square root of the variance, right? Okay, so you see that both these give the same answer as they should, right? All right, next thing is how to access a certain element of X. Suppose, okay, this is your X, right? It's a vector of length 9. Now, suppose you want to access a certain element of X, suppose the third element, which is 4.9. You just type X in square brackets 3. That gives you the third element of the vector, right? Now, you should type, on the other hand, you should type this. What this does is it removes the third element from the vector. So you see, if you remove 4.9, it gives you 1.4, 2.7, 5.5, up to 16. Right now, you should type something like this. What it does is it picks the second to the fifth element in the data set. So it goes from 2 to 5. So it picks the second, third, fourth, and the fifth elements, which are 2.7, 4.9, 5.5, and 7.8. Right? Now, if you type something like, excuse me, you should type something like this, right? Then it will pick the second, the fourth, and the eighth elements in the data set. So 2.7 is the second, 5.5 is the fourth element, and 15 is the eighth element in the data in the vector, right? All right, now if you do something like this, it will pick the values in X which are greater than 12. So basically, these three values are the values in X which are greater than 12, right? Now, let me retype X. Okay, now if you do this, you should do this, where the vertical bar here means all, right? You should do this. What you're asking for is that all the values in X, all the values in X for which X is less than 2 or greater than 15. So let me type again one more time. This means all, right? Okay, so this picks all the values in X which are less than 2 or greater than 15. Yeah. Now, next is, suppose you want all the values which are greater than 6 and less than 12. Then, so here, this means and, right? So here you're looking for all values in X which are greater than greater than 6 and less than 12. So there are only again two values which are greater than 6 and less than 12, namely 7.8 and 10.2. All right, is it Alexandra? Alexandra, for all you use the vertical bar. So the vertical bar means all, right? No, it is not the letter L. It is not the L. It should be on the right-hand side of your keyboard. I don't know, maybe I think the keyboards are, yeah, above enter. Yeah, exactly. Yeah, got it. Yeah. Okay, yeah. Yeah, one person asked me to repeat something. I forgot, just a minute. Yeah, okay, I will repeat that one more time. Okay, X2 to 5, what this means is that it picks all the data from the second position to the fifth position. So that means 2.7, which is the second position, third position, fourth position, fifth position. So it's 2.7, 4.9, 5.5, and 7.8, right? Okay, guys. Right. The next thing I'm going to talk about is logical operations. Uh, oh yeah, I will explain that in a minute. But let me answer that question in a sec, okay? After I do this. Now, x contains nine elements, right? Now, you should type x greater than 5. You should type x greater than 5. It will give you this. So what this means is that it checks whether every data point in the vector is greater than 5 or not. So 1.4 is not, 2.7 is not, 4.9 is not. So the first three are false, and the remaining elements are greater than 5, so they are true. So this is like a true or false vector. A vector contains either true if the condition is satisfied, or false if the condition is not satisfied. So, for example, you can assign this to an object called LV, right? Then LV will contain these values, right? Okay. Now, one other thing I want to say is the following. Now, x greater than 5 give this vector with false, true or false, whereas this gives something completely different. You see, these two commands are similar. They're very similar, actually, but the outputs are very different. The first one gives you the first command, which is this one. It checks whether the condition is satisfied or not, right? So therefore, it gives you either true or false value. The second command, which is this one, it looks for the values in x which are greater than 5. So it gives you these 6 different values which are greater than 5, right? Basically, these 6 values here, right? So although the commands look similar, they give 2 different outputs. All right, now one person asked me a question. I think this is a very important question. I think very good question. Now, excuse me, just give me a sec, guys. Use to apply and right. Whenever I use a round bracket, and there's a difference between a round bracket and a square bracket. Whenever I use a round bracket like this, I mean the following. That is, I'm using an operation, like for example, a mean, to something that is contained within the round brackets, which could be a data set. So for example, this mean of x gives you the average value of the data that is contained in x. Now, whenever I use the square brackets, right, is used the square bracket is used to extract part of a data set. So for example, right, this picks, right, x square brackets 3 picks the third data set in the data contained in x, right? All right, so there is a big difference. Well, whenever I use a round bracket like this, that means that we are applying an operation to a data set that is contained within the round brackets, right? But whenever we use the square brackets like this, that means you are extracting part of a data set. Like here, you are extracting the third data point in X, which is contained in X, right? So these 2 commands are used for different purposes, right? Okay, is that clear to all of you? I mean, let me know. I mean, you will see, I mean, as we go along, you will see like what the difference between this and this is, right? Okay, all right. Now, before I go ahead, let me list the possible operations that you can have. So this means less than, right? And this means greater than, right? And excuse me. And the next one, this means less than or equal to, right? And this this means greater than or equal to, right? And this double equal sign means equal to. And this means not equal to, right? And if you have a vertical bar like this, it means I think I already said is all, right? And finally, if you have this symbol, right, that means and, right? So these are the operations that are commonly used in R, right? So now let me illustrate them. For example, suppose C1 is a vector, that contains true and true, right? And suppose C2 is a vector that contains true and false. Okay, right? Now, if you type C1 and C2, you will get this, because I'm sure you guys have done Boolean algebra, right? So true and true is equal to true, whereas true and false is equal to false. Now, if you type C1 or C2, you will get true and true. That's because true or true is true, and true or false is true, right? Now, if you type negation of C1, you will get false, false. That's because the negation of true is false. The negation of true is also false, right? Okay. Yeah, so I should have said, sorry, I forgot. This means negation, right? Okay, whenever I use the exclamation mark, it means negation. So for example, if you say this, you will get false and true, because the negation of true is false, and the negation of false is true, right? Okay, so, all right, now let's go back to the tutorial sheet, which is this one. Any questions so far, guys? Let me know, please. I'm here to help you guys. So there are two exercises that we need to do on page 6. On page 6 of the tutorial sheet. This is exercise 1. This is exercise 2. So let's start with exercise 1. So here you have two vectors y and z, and we need to do these manipulations, right? Okay. So let's try to do that. So this is exercise 1. So the first thing you need to do is to create the vector y, which contains the numbers 1, 2, 4, 12, and 16. The second thing we need to do is to create the vector z, which contains the numbers 3, 4, 8, 9, 15, and 18, right? All right, y minus 3 is simply this. So what it does is it simply subtracts 3 from each element in y, right? Z times 3 plus 1, sorry, excuse me, I did something. Z times 3 plus 1 is this. So what it does is it multiplies every single element in Z by 3 and then adds 1. So you get this as the output. The median of y is 4. So remember, the median is the middle value in y. Okay, so if you arrange the data from the smallest to the largest, median is the middle number. And the median of Z is 8.5. Okay, and next sum. Okay, let me type Z now. Sum of Z when Z is greater than 10. Now what this does is it sums all the values in Z which are greater than 10. So basically these two, right? So if you sum 15 and 18, you get 33, right? Now the next thing is mean. Mean of the values in Y from the second position to the fourth position, that gives you 6. That's because of the following. You see, this is your vector Y. And the second data point is 2. The third is 4. The fourth is 12. So if you take the average, if you take the average of these 3 data points, you will get 6, right? All right, next. Next is the mean of Z, excluding the data points from the fourth position to the sixth position. This is what you get, because now if you exclude the data points from the 4 to 6, which means these 3, if you remove these 3 data points, that's what the minus means. The minus means that you remove the data points from the 4th to the 6th, right? So if you remove these 3, then the average of the first 3 is equal to 5. Okay. All right, guys. All right. Next, excuse me. All right. Next is y plus z. Y plus z is undefined because remember, y is of length 5, whereas z is of length 6. You can't add 2 numbers that are of different length. I mean, you can't add 2 vectors, y and z are of different lengths. So y plus z is undefined. Right? I'm sure you know that, guys, right? If all right, I've got a question from Zahra. Why do we use round? Yeah, that question. I mean, you don't need to use the round bracket. It's just to be safe. Just to be safe, I used the round bracket. I mean, you can do it. You know, just to make it clear that we are removing the data from 4 to 6. I just used the round bracket, but there's no need to use. I mean, I think otherwise it will look kind of ambiguous, right? So just to make it clear that I'm removing the data from the 4 to 6, I just used the round bracket. Okay. Right. The next one is sum of y. All right. Before that, let me type y. Right. This is y. Now sum of y greater than equal to 4. So what this does, guys, is it looks for the number of values in y that are greater than equal to 4, which is 3. Right. So these are the 3 data points that are greater than equal to 4. Whereas if you do this, you will get a completely different answer. Right here, what this command here, what it does is it sums the values of y that are greater than or equal to 4. So 4 plus 12 plus 16 is equal to 32. Right? Whereas this command here, it it looks for the number of different values of y that are greater than or equal to 4, which is 3. These are the 3 data points that are greater than or equal to 4. All right, so these two, I think I mentioned this before. These two commands, although they look similar, they are not the same, right? Okay, this gives the number of values in y that are greater than or equal to 4, whereas this gives the sum of the values in y that are greater than or equal to 4, right? All right, so that completes exercise 1. Now let's go back to the tutorial sheet. So this is the tutorial sheet. Now the next thing I'm going to do is I'm going to do exercise 2. So here you have this data set, which are closing prices, daily closing prices. The first thing to do is to read the data. The second is to find the minimum, maximum, range, mean, and the standard deviation, and so on. All right, so let's see how we can do this. Okay, now this is exercise number 2. So the first thing I'm going to do is to read the data. So to read the data, you just type it, all right, 38, 42, 44, 43, 46, 48, 52, 54, 50, 47, 48, 48. Oh, sorry, I made a mistake, I think. Oh, I forgot to put the sign here. All right. Okay, so I have read the data as, right? I have read the data into an object called S, right? So S contains the data values. Okay, guys. Now the first thing to do is to compute the minimum. So to find the minimum, you just say min of S. To find the maximum, you say this. To find the range, remember the range is the difference between the max and the min. All right. And to find the mean, use the command mean. And to find the standard deviation, you use the command SD. Right. So this completes part 2 of exercise 2. Now part 3 is telling you that the first value, which is currently 38, should have been 48. Right, so this is the first value, right? And it says it should have been 48 and not 38. Now to change that, what you need to do is simply this. So you see what I'm doing here? I'm assigning 48 to the first data point. Now if you type S again, you will see that the 38 has changed to 48, right? Okay, and the next part is to find the percentage of days when the closing price was less than 45. All right, now to do this, first you need to work out how many of the closing prices are less than 45. And so there are 3. So the length of the number of days when the closing price is less than 45 is 3. And you divide this by the length, the total length of S, and then you multiply it by 100. So the answer will be 25, or 25% of the days have closing price less than 45. And the final part is to use the diff command. Now, what diff does is the following. Now, -6 is the difference between 42 and 48, right? 44 minus 42 is 2. 43 minus 44 is -1. 46 minus 43 is 3, and so on. Right? So this diff command is basically takes the differences between successive values of the data. Right? Because of the way the diff works, the length of diff is always 1 less than the length of S. Right? You see that the length of diff is 11, whereas the length of S is 12. That's because because of the way the differences work, is always one less than the original length of the data. All right, guys, are you okay so far? Any questions so far, guys? Feel free to ask me. No questions? Are you sure? Use the chat box, guys, if you have questions. Okay, thank you. All right, the next thing, all right, the diff. Yeah, the diff takes the differences between successive values of the data. So for example, 42 minus 48 is minus 6. 44 minus 42 is 2. 43 minus 44 is minus 1. 46 minus 43 is plus 3, and so on. So it's an operation diff means it takes differences between two consecutive values. I mean, two values that follow each other, right? Like 48 and 42 and so on, right? Okay, now let's go to the next page, which is this one. Now, in the next page, I'm going to show you how to read a data file. Right, to read a data file, go back to the website. There are two data sets in this. The first one is called Moses. So Moses is a data set which contains time of the running times of different people. And as you can see, the name of the column is called time. Now, if you want to read this data set, what you need to do is simply copy the URL, right? So copy, and then go back to R and paste it, right? And then you type this command read.table and put that in quotes, double quotes, okay? And then you say header equal to T for true. The reason I'm saying header equal to true is because if you go back here, you see this data set has a header, which is time. So we need to tell the computer that the data has a header, right? All right. So now let's assign this to a variable. I mean, you can call it any name. Let's call it Moses, right? So this is what you will get. Now, if you type Moses, you see the data that I have read. So this is the data that I've just read. So it has two columns. The first column is a counter column, which you can ignore. The second column is the data that we read, right? Now, if you want to access the second column, you need to say the following. You need to say Moses $time. So Moses the name of the column, right? It's always like this. Now, in this data, you only have one column apart from the counter column. So you just say Moses $time. But if you have multiple columns, then you need to say Moses the name of the column, right? Okay. All right. Now the question is asking you to do some summary statistics. So for example, if you want to find the minimum running time, you say min of this. So this is the minimum running time. The maximum running time is this. The median of the running time is this. The mean of the running time is this, and so on. All right. And it's also asking you to find the proportion of times when the time was less than 47.5. So to do that is similar. So you basically need to find the proportion of times when the time was less than 47.5 seconds. So you need to take the length of this, right? You need to take the length of the data when the time was less than 47.5 seconds and divide it by the total length of the data, right? So this is the proportion of times the proportion of the data when the running time was less than 47.5, right? And if you change this to say greater than 49.5, what you get here is the proportion of the data when the running time was greater than 49.5 seconds, right? All right, guys, so this is just a simple exercise on how to read a data set and how to do some simple statistics of the data, right? The next thing I'm going to talk about is categorical data. So if you look at page 8, I hope you have a copy of the tutorial sheet, which is on page, if you look at page 8 of the sheet, there's a section on categorical data. Categorical data is basically, I mean, it happens all the time. So for example, if you ask somebody, if you ask someone whether they smoke or not, or whether they drive a car or not, or whether they drink or not, then the answer is likely to be either yes or no, right? So let me just type this data, right? Give me a couple of seconds. Okay, to type this data. Right, so I just typed the data, which contains the values yes or no, right? Right, so if you type response, you will see these are the data that I just typed, right? Now, a simple way to summarize the data is to use the table command. So what this command tells you is that there are eight people said no, and 7 people said yes, right? So there are, okay, so it's a summary of a categorical data. Now, another way of representing categorical data is to use the factor command. Now, a factor command is used, it's used like this, right? Right. Now, if you type response F, you see, again, you get yes or no, right? And if you type levels of response F, you get two different levels, either no or yes. Now, suppose the thing with the factor command is that you can change the levels to anything that you like. So instead of calling it no or yes, you can call it, for example, 0 or 1. So 0 corresponds to no, and 1 corresponds to yes, right? So now if you type response F, you see that the data has been recorded. The data has been recorded in terms of ones and zeros. Instead of yes and no, instead of yes or no, you have a data recorded in terms of ones and zeros. So 1 corresponds to yes, and 0 corresponds to no. So that's the beauty of using factor command, right? All right, the next thing, the final thing on the tutorial sheet, I know I have only 1 minute left, but give me like a couple of minutes. Okay, I will just finish this off. So if you go back to the tutorial sheet and the very last page, right, it's saying that you read the data from this file, which is this one. So here, what you have is a party data set, and there are 5 different digits, 1, 2, 3, 4, or 5. And these 5 different digits correspond to 5 different parties, right? And the question is asking you the following. The question is asking you to read the data first, which I'm going to do right now, right? So let me read the data, right? Just give me a sec, right? Read dot table in bracket this, and then you say header equal to true because the data has a header, as you saw. You see the data has a header which is called party, right? Now, what I'm going to do is I'm going to, excuse me, I'm going to type poll. You will see the data set here, right? You see there are two columns. The first column is basically a counter column, which you can ignore. The second column is the party column, which tells you which party people voted for, whether it's number 1, number 2, number 3, number 4, or number 5, right? Right now, the purpose of this exercise is to convert the numbers into actual names, right? So what you need to do is the following. You need to convert the data into a factor first. So use the factor command first, right? And then you will look at the levels of the factor, which are, at the moment, they are the numbers 1 to 5. Now we want this changed to the actual names. So 1 corresponds to the Conservative Party, right? 2 corresponds to the Labour Party, right? 3 corresponds to the Liberal Democrats Party, and 4 corresponds to the UKIP Party, and 5 corresponds to other parties, right? All right. Now, if you go back and look at polls F, right, you will see that the data has been recorded. You see the data has been, now the data is actually in terms of the names of the parties than the numbers 1 to 5, right? Okay, now finally, if you want to use the tables command, if you use the table command, it tells you how many people voted for each party. So 369 voted for Conservative, 314 for Labour, 75 for Liberal Democrats, 118 for UKIP, and 124 for other parties. All right, so this completes the exercise and also completes the tutorial sheet. All right, I'm sorry, I ran out of time by 2 minutes. I'm sorry for that. You have any questions, guys, you want to ask me now? Scroll up, yeah. You want me to scroll up, yeah. Any questions, guys? Are you okay? Okay, Alexandra. Yes, if you have any, questions you want to really ask me, just, you can contact me 24/7 by email, phone, Skype, or Zoom. I'm available all the time. Okay. Yeah, I put the header to be equal to true. No, I don't put anything on Blackboard, Alexandra. Alexandra, I put things on the Minerva website, which I showed you before. So you'll be able to see copies of the videos in this website here. This is the website, Alexandra. This website will contain all the videos from the session, from every session, whether it is a review session or whether it is a video tutorial session. You will see the videos appearing in this website, not Blackboard, right? Okay, guys. So have a good time wherever you are, and once again, please feel free to contact me 24/7 for any questions. And finally, happy Chinese New Year for happy Chinese New Year for all of you guys from China. The Chinese New Year is on Friday, I believe, Friday, the 12th of February. Have a great time, guys.